This is the solution of classical 2 quiz. Okay, now we start with reading the question. Here we have a system of two objects of masses m1 with 2 kilogram and m2 with 3 kilograms and drawn like this. So I'm going to draw them beside each other. Here we have m2, which is a little bigger than m1. Here we have m2 and here we have m1. Okay, sorry for the miss circles. Okay, now here we have m2 and m1 with their masses is at rest as shown below. If m1 moves with constant speed of 2 meters per second, so we have v2 is equal to 2 meters per second towards the east, while m2 remains at rest, so towards the east. Okay, here the first part we need to calculate the linear momentum of m1 with respect to the center of mass. Okay, so we have to calculate p of m1 with respect to the center of mass, so it is prime. Now to calculate p1 prime, we have to calculate v, because it is equal to m1 v1 prime. Okay, now we have to calculate v1, and to calculate v1 prime we have to know its equation. So I'm going to draw here the coordinates to find the center of mass and to find the... Okay, I'm going to draw them like this. We could put them on the x-axis, but I'm going to put them like this to draw the arrows easily. Here I have from the center of my graph to m2. This is r1. Okay, and if I have the center of mass between two of them, both of them is here, for example, I think it's nearly here, I'm going to draw the r vector, which is from the origin to the center of mass, like this. So this is r, and the distance between them from m2 to the center of mass is going to be r1 prime. So I'm going to draw r1 prime like this. Now r is the same for both of them. I'm going to draw r2 like this. So this is r2, and of course here we have r2 prime. Okay, so now we have this drawing. We can get two equations. We have r1 prime is equal to r minus r1 gives us r1 prime. I think there is something wrong with the signs, but it's okay. Okay, so r1 minus r center of mass. Now deriving this with respect to t, we have v1 prime is equal to v1 minus v center of mass. Okay, and v center of mass, we know the rule for it. We know the a way to find it. We can get it from m1 v1 plus m2 v2 all over m1 plus m2. Okay, Now, getting back here, we need v1 prime, which is here. We will substitute both of these in this equation. Now we can get p1 prime as a vector is equal to m1, we know it, multiplied by v1 prime. Okay, I'm going back here to put the numbers, or I'm going to continue. Okay, getting back here, we was writing this equation and we need to substitute these before we're plugging in them in the previous equation. So I'm going to write in the calculator. Now we have m1 v1, where m1 is 2 kilogram and v1 is 2 meter per second, plus m2, which is 3 kilograms multiplied by 0 because it's at rest, and which is down here is m1 plus m2, which is 2 plus 3. We get 4 over 5, which is 0.8. So we have v center of mass, which is equal to 0.8. Now we're going to plug this value in this equation. We have v1 prime minus 0.8. Okay, this seems odd. Okay, now I'm going to plug a v1 prime, which is okay, here we plug v1 without prime, v1 minus v center of mass as we got here, and v1 is the velocity of the first object. So we have p1 prime is equal to m1, which is 2 kilogram, multiplied by v1, which is 2 meter per second, minus 0.8 meter per second. Now we can get here 2 multiplied with 2 minus 0.8, which is 12 over 5, which is 2.4. And of course the here we have kilogram meter per second, which is Newton per second. Newton second. Now for the second part of the question, we have part 2, which says the linear momentum of m2 with respect to the center of mass. Now we have the same thing that we've done to part 1. We are going to do it for part 2, but changing r1 and v1 with r2 and v2. Now we have p2 prime is equal to m2 v2 prime, and we have m2 v2 prime is v2 minus r center of mass, or v center of mass is the same for both of them because it is the center of mass not related to any of them. So we got here 0.8. p2 prime is equal to m2 is 2 is 3, m2 is 3 multiplied by v2 is 0 meter per second minus 0.8 meter per second, and we have here 3 multiplied by 0.8, 3 multiplied by 0.8, which is 2.4. Okay, here we have minus 0.8. Okay, so minus 0.8, which is a logical or reasonable answer because we have to have a zero total momentum with respect to the center of mass. Here P2 prime Newton per second. I think this is not its original units. We can just write kilogram meter per second, and they are the same. Okay, now we have got 2.4 Newton per second for the first object, and 2.4 for the second object. Now the third thing, which is the total linear momentum of the system with respect to the center of mass. So we have here P total for 3. P total is equal to P1 plus P2. And here we have P1, as we found it, is 2.4 plus minus 2.4 for the P2. We got 0, which is clearly stated in our book that the total linear momentum of the system with respect to the center of mass is always 0. That's all for our quiz. Thank you.